So a few weeks ago I looked at the fidget spinner kit, and now I found another one. So completely different design. I thought it'd be interesting to put this one together as well. So a very similar sort of case to the other one. Circuit board. This time it's got a lot of surface mount components, and you see the LEDs here are all going to be surface mount as well. So let's see what we've got in here. So we've got some plastic axle to go in the holes in the centre of the case. And in terms of components, so we got some surface mount resistors, 2, 3, 4, 9 surface mount resistors, and that says 101, which I think should be 100 ohms. We got some red LEDs, so four red LEDs. So they've actually put like a coloured marking on here, which is quite useful, so you can see which LEDs are which. So those are red, and then there's 4 blue, 4 green. There's the clip for the battery, so that needs to be soldered down to the case, to the PCB rather. Oh, there's another one. So there's right. So there's two batteries, one each end. So I need 2 CR2032s. There's a little bearing. So that's the central mechanical piece for the fidget spinner itself. What else? Oh, I think this might be a tiny magnet. Yeah. So there's a tiny magnet. And I guess that fits in the case somewhere. I'm not sure, but I presume what that's about is that there'll be a Hall effect sensor. Could that be this device here? So we've got a three pinned device. That could be a transistor, of course. But I wonder if it uses a Hall effect sensor to sense the rotation. So when the magnet goes past the sensor, you get a little pulse. Got a couple more resistors there, looks like 105, so that's 100k or 1 meg, I'm not sure, I'll have to look that up. There's a small on-off button. That looks like one of the green LEDs has escaped there. These components really are very tiny. And then finally we have a chip. So that says STC 8F2K 16S2. So that'll be a microcontroller, presumably that they've already programmed in the factory. And so I expect this to be rather more sophisticated than the previous fidget spinner that I created, that I assembled. If you haven't seen that, by the way, I will put a link up here. But the other one was just made out of a few discrete components, so it just basically made some some line patterns, but I think this one's going to have some more exciting sort of visual displays. Right, so I'll warm the soldering iron up and get started adding some of these surface mount components. I'm looking at how these components fit into the board. Unfortunately, looking at the Aliexpress site, the page for this fidget spinner kit, actually the information there is for a different kit now, so it shows discrete components and it shows various shots of the board which show that it's not this one. So I'm flying blind a little bit on this one. I have to kind of guess because there's not much information available. But let me see. So I looked at this thing that looks like a transistor. I think this is called the SOT23 package. So there's a space here that says U2. So U is normally the designation for a chip. So we see down here we've got U1, which is where the microcontroller goes. So U2 would seem to be the Hall effect sensor. And if you look at, so like these spindles they give you for the center of the hub, there's a little recess here which is obviously big enough for that tiny magnet we saw. So that tiny magnet fits in that hole, so then when it rotates it's going right past this sensor here. So I haven't quite figured out what goes in this R0 yet, but in terms of the LEDs, so you know, a reasonable value for a current limiting resistor for a LED is 100 ohms. So we have all of these tiny 100 ohm surface mount resistors here, so I'm going to fill these in with the 100 ohms, but also these ones down here, if you follow the trace up here, there's like a common negative trace, I think it's negative anyway, that covers the bottom half of the LEDs, and then there's another one that covers the top half of the LEDs. There's a track going down here joining them all, and those go through more resistors here, so I'm guessing that these are also 100 ohm resistors because they're going to be in series with the current for these LEDs. So I'm going to start there and put these components in place and then try and figure out the next step. There, so the resistors are in place now. That's not very pretty soldering work, but I've inspected it with the magnifying glass and it looks like there's good electrical contact. And so I'll put some of these other components on, like there's a switch to go here, there's the Hall effect sensor. So when I looked using the magnifying glass, you could see some writing on it. It said 253DL. Now I haven't been able to find exactly what type of Hall effect sensor that is, so I'm still not sure what resistance value is required here. But I have now actually used up all of the 100 ohm resistors, so I would guess that one of these 10k or 100k, whatever they were, resistors goes in here. So the 105 marking, 105, it actually designates 1 meg ohm, so 1 0 followed by 5 more zeros, so that's a 1 meg resistor. And I should probably have an outtakes video actually to suit for, you know, with me swearing at the SMT components, because a couple of times what's happened is if you grip these components too hard with the tweezers, they can ping out at high speed and disappear off and because they're so small and light, they can go quite some distance, and then you're searching round, you know, searching round for an incredibly tiny component which you don't know which way it pinged off. Anyway, so I've got the switch on, I've got the assembly for the Hall effect, so all that remains is the, I know there's the battery boxes I have to put on, but other than that there's the chip itself, so I have to make sure that that's in the right orientation. So the dot, pin 1, is on that left hand side there, so actually that's the right way round for this board now, because it's got like a cutaway on the diagram on the board. So I'll put the chip on, and then I'll have to figure out which way round the LEDs go. I presume that this is the negative side, so these will always all be the cathodes, but I just need to double check that before I commit to putting all the LEDs in place. So once again, not very pretty, but I've got all of the legs soldered in place, no solder bridges between the legs, so that looks good. There's another couple of pads here I noticed. I'm guessing that these are test pads because there's no silk screen on the board to indicate that a component goes there. This is interesting as well. On the side of the board you've got VCC, RX, TX, ground. So TX and RX obviously means a serial port, so I think I'll connect some wires to there in a little while. When we've got the power on, I think I might connect something to that, see if anything comes out of the serial port. Might be interesting to see if there's like some debug in the microcontrol program that's sending something out to the RX port, or maybe the TX port, if that's transmit from the chip. But we can look at that. So I need to work out about these LEDs. I had an idea, which was to fit the battery boxes on. So you see I've soldered these on. They solder on the top. I guess you could put solder on the bottom side as well for rigidity if you wanted to, but and you see you leave the open side at the end there to make it easier to put the batteries in. But I thought I might put the batteries in and see if I can detect the VCC and ground here, see if I can see a voltage on here, and then if that's working I've got a little experimental LED here, so then I could just sort of touch a LED on here and see if it flashes, or if I can't make good electrical contact I could just sort of put a dab of solder on. So this is a funny LED actually. That's one that changes colours. Let's see if I can find a normal LED. Alright, so I've got a red LED. I think this battery might be a dud. .8 volts, that doesn't look very good, does it? and this one's 3. Yeah, so that's a dud battery. Okay, so I've got a couple of decent batteries. There we go, so we've got 3 volts there. So let's try putting the lead on here, see what happens. Okay, so the anode looks to be on the left there, and then all these ones that were commoned up. So is that right? Oh no. So the longer lead is generally the plus. So the ones that are commoned up are actually the plus 3 volt side. So I presume this LED is just flashing so fast that it looks to the eye like it's continuous light. Right, so with that information I can actually solder on some of these surface mount LEDs. Now I'm not sure what kind of pattern it needs because so there's obviously 2 groups of LEDs and there's no guidance as to which is which. So what do? Do I just do red, green, blue, red, green, blue? I'm not sure. That would be 6 in each group, wouldn't it? Yeah. Yeah, well in the absence of any other information I think that's what I might do. So there, I've got the first LED in. So started doing red first. So these surface mount LEDs, I don't look at these very often, but I can switch that off. Let's just pop the battery out for a second. So I hope this shows up on the camera. These are incredibly tiny, but so there's a green mark on the top of the LED, which is obviously denoting the cathode. So I put the green mark to the right, but also if you flip these LEDs over, you can see a little green arrow, and that's pointing from anode to cathode. So you got the green arrow on one side, and if I can flip it over, don't know if that's focusing actually, but the and then you can see the cathode denoted with a blob of green on the other side. But of course you can do as I did and just have the batteries in when you're soldering it, and then you can see whether it's going to come on or not. So I'll continue red, green, blue all the way down to the bottom. Okay, so I've got all the reds and greens in. There is one blue here at the top, D3, but it does seem incredibly dim. I have seen it light up a couple of times, but it seems very dim. I'm not sure if blue LED is a good idea, because this is running very low voltage. It's only 3 volts, and the blue won't light until 2 volts. So I wonder if that's a practical design. So I'll have a look around in my bits box and see if I can find some more surface mount LEDs. I think I've got a few, and I might just get rid of the blues and put something else in there. In the meantime, I think I will assemble the rest of this. So we've got the bearing that has to fit in there. Circuit board. So we have to put the tiny magnet into its slot. So that'll be the top one close to the sensor. And then that locates like so, so you can get the on-off button. Let's try and get that one in place. Right. Well, it's quite bright in here at the moment. We might have to wait till it gets a bit darker to get the full effect. But you can see some patterns happening there. Not sure how many modes it's got. Maybe only 2 modes. Anyway, in the meantime I'll try and seek out those other LEDs. Okay, so I managed to find a couple of yellow LEDs. That one at the top, the third one down, is green, although it's not lit at the moment, and the one at the bottom is still a blue. I couldn't find enough LEDs to do the whole thing really, but there we are. I've put the screws in the case, so that's fully assembled now, and as I said, we'll have to wait till I can put the lights down so that we can properly see the effects that are available.